This is a deep dive into traditional and modern auth technologies. What we're going to cover today, we always like to do certificates 101, just a quick review. We'll cover Radius and also Radsec. Right, Radsec is somewhat, it's a very old protocol, but it's kind of new to the networking world in actual use. We'll do an 802.1x and Eep review, and then we'll kind of transition to what I call the modern mechanisms, Saml, Oauth2, Openid Connect, and some fun new stuff called FIDO2. So just really quick about me and my contact information. I'm an engineer on the security product team, responsible for identity and policy architecture, cloud identity, programmability, all that fun stuff. So we used to put all of the Boston banners on our title slide, but they don't fit anymore. So we went back to the sports logos, so sorry about that. All right, so let's jump into certificates 101. Also, if you want me to slow down, I cannot control my speed, so just let me know. I also discovered the emoji keyboard in PowerPoint is literally one of the greatest add-ins. They have everything. All right, so let's start with certificates, right? Like I said, this will be an intro and then a little bit deeper into it. But ultimately, the whole idea with certificates, X509 certificates, is to prove trust for a digital service, right? And that could be a person, or that could be a company or a resource, right? So if you look at, when you go to arubanetworks.com, ultimately, Aruba has proven themselves to, in this case, DigiCert, as the owner of this domain. And in this case, it's actually what's called organizationally validated. So they have proven that, in this case, it's going to be Hewlett-Packard Enterprise, because that's the legal name of the company, that they are who they say they are, and that they, at some point in time, when they requested the certificate, they had ownership of essentially the key, right? The key that owns, the key that can actually present this identity to us. So at the top here, you'll see DigiCert Global Root. You'll see another one called DigiCert ECC Secure Server CA, and then at the bottom we'll see what's called the Leaf certificate, which is www.arubanetworks.com. Now the whole reason that there's more than, right, a lot of people ask why is this here, right? Why can't we just do this? This CA, for example, has been in root stores for probably 15 years, right? These are the most important ones at the top, the roots, because ultimately those are what's included in the device operating system. These middle ones, the intermediates, the signing CAs, those are much more short-lived, and they're much more purpose-built, right? So in this case, more and more services are using what's called elliptic curve cryptography. The idea with that, we could spend a whole session on that, but ultimately, much stronger encryption levels in a much smaller size key, right? And that's really huge, and you'll start to hear more from us in terms of changing best practices around elliptic curve certificates. Most browsers support it, but the device side for something like Eep and the network side is not quite there yet. But ultimately, all your device generally has to start is about 30 or so root CAs by default, and then they'll download additional ones via Windows Update, Mac Update, iOS, etc. But ultimately, to get this cert into your root store, every operating system and sometimes browser manufacturer has their own policy as to how to include these, right? Because ultimately, given the different levels of trust this proves, all the way down 2 tiers, this could even be 5, right? There could be 5 intermediate tier in the chain. That's a pretty privileged action to include that in an operating system. So essentially what happens is the root inclusion program, that's the kind of the general name, has a very, very, very heavy check on business practices, auditing, all kinds of fun stuff. Like DigiCert has to have, let's say, don't quote me on this, 2 of the 4 global accounting firms auditing all of their records to ensure that they are properly verifying HP and Aruba's identity to get the certificate, right? So there's a lot of things that have to happen before the OS vendor does this. The really interesting one is Firefox. So Firefox is unique in that it maintains its own certificate store across platforms, right? So the Firefox certificate store you have on Mac is the exact same certificate store you have on Windows. And they did that because they wanted to maintain the trust is with Firefox, not with the OS vendor. Because ultimately, every company you add into that mix can be influenced by money and scandals and all those things that cause those problems. So Firefox has taken that stance. Firefox is an open source company. They're a nonprofit organization. And you can actually see every single decision that is made for Firefox in terms of inclusion of a new root CA. They do it on public listservs. You can comment. Anyone can comment. And the reason I bring it up is recently a CA out of the Middle East. It is a normal public CA, but they were kind of caught doing some not so great things for one of the Middle Eastern countries' government, and they ended up getting rejected into the Firefox program, even though they had a perfectly legitimate business over kind of on the side for normal certificates, right? So that's where a lot of this churn has been happening in the industry. Like about 2 weeks ago, for example, you saw Facebook, Google, and Microsoft had to revoke a ton of certificates. There really wasn't a whole lot of, what they did wasn't bad, it was actually a bug in a piece of software where essentially the serial number of the certificate has to be X bits, right? And because of some weird code stuff that's above my head, it didn't come out as that number. They all kind of got notified of it. And like I said, this wasn't a big deal, but to show that they are following practices that are established by the industry, they went through and revoked them all and reissued, right? So it's all, literally, I know it's cliche, it's all about trust, and it has to start back at those companies. And there has been a lot of churn, right? I would say the top 10 CAs that existed 5 years ago is down to 2 or 3, right, in terms of the most popular. So you're really down to DigiCert, Sectigo, and really those are the 2 big ones. That's where most of your certificates come from these days. In terms of what does it actually prove, right? Your client needs to ultimately prove that it's a trusted issuer, right? And I just covered how that gets into your device, right? That's really not out of the box. That's a decision the operating system or the browser manufacturer has made, but you can obviously include additional trust. The device needs to verify that the certificate is not expired, right? These are essentially the core ways to validate, and that it's not revoked, right? So those are the three bases of either a server or a client certificate authentication. Or identity check, right? Beyond this is really into authorization, right? If you want to do additional checks to say this certificate has this subject alt name for this service, or it has a certain OID, which is essentially custom attributes, that's all really part of authorization. But nearly every SSL stack, or TLS stack that you use in some form of platform really has to get past this point. I also discovered a lot of transitions in PowerPoint 2019, so sorry. So let's cover what actually is a certificate. Ultimately, it starts with a public key that you give, right, as by nature public, and a private key that you have. And ultimately, we take a public key, and then we generate a certificate signing request, and we send that combination over to a certificate authority, right? That's the process of you uploading it to a CA. And ultimately, what they do is they hash it all together, sign it with their keys, and then that is the resulting certificate, right? So think of it as just a public key plus a bunch of data. And that data is what that CA is attesting to based on their agreement with you as the organization or end user. So how do you actually start with this, right? So you start with a public key. That's what a raw public key looks like. You don't often see this because most times you're implementing some form of public key cryptography or using certificates. And I'll talk a little bit at the end as to how this is changing a bit. But public key cryptography by itself without X509 cert is not commonly used in mainstream implementations, right? You're ultimately attaching a certificate to this. So you very rarely see this. You do often see the private key, right? I mean, that's something you have to protect, is the most critical piece of all of this. And the relationship between those, this is another thing we could do probably an hour on. Ultimately, it's a multiplicative inverse. It's such a hard word to say. Multiplicative inverse, right? So these are related, and they can reverse each other, and only they can reverse each other. It's logarithmic functions way beyond. Wasn't great in algebra. If you want to hear more about this, talk to Dan Harkins. Get a beer, though. It'll be a half hour. He'll take you through the entire thing. But ultimately, these are related, and those are the only 2 things related, and they are the opposite of each other. And so what that gives you is attaching to a CSR, right? So that public key gets attached to the CSR. I keep a copy of the private key. In an application, that's generally going to be stored in the application. If you do it on, and you do it on your laptop, the key is on your laptop. Not a great thing, but it is what it is. And then you ship the CSR off to the CA. What they're going to do is essentially read the public key, which I've actually removed because it's too big. And they have some properties here, like it's a 2048-bit RSA key. And here's the requested subject, right? So that's what I put into the CSR, and that's what I want to request it be signed as, right? So in this case, it was a wildcard certificate, star.arubasecurity.net. Now, the CA doesn't have to honor that if they don't choose, right? Sometimes you'll have a CA actually have you type it in to verify that it matches, and they'll actually just override what you had in the CSR. Because ultimately, really what matters is the public key. On the other slide, the public key. This doesn't really particularly matter to the CA, but generally they're going to accept what you have in the CN. That's why most CAs will not have you send a CSR with a SAN. They'll ask you to just type it in on the web page. The result is the final certificate, right? The CA has gone through, taken the public key, as we saw in that diagram, mashed it all together, added their data, and ultimately signed it to say that they issued it. So if we look through, this is kind of the textual view of a certificate. We have the unique serial number. This is what I was mentioning that piece of software was not generating this correctly. You'll notice the serial numbers are not incremental. They are randomized by design. So that is what caused the three major tech companies to have to reissue certificates because that wasn't long enough. You end up with the actual issuer's name, right? So this is the CA who signed it, so that's going to be that intermediate certificate, not the root. You'll have the validity, right, in the middle, which I didn't have a sign for, sorry. Not valid before and not valid after. And then you'll have the modified subject name. So you'll notice, like, I did not request a certificate with OU domain control validated, OU positive SSL, blah, blah, blah. All I did was request CN equals arubasecurity.net. The reason that that was added is this was a cheap certificate that only did domain validation, right? So they can't say that, you know, if I put in, let's say, Aruba Networks as the organization, they can't attest to that because I didn't prove I was representing Aruba. I only proved that I own arubasecurity.net. So that's why they fill this in with domain control validated. So ultimately, domain control validated is the cheapest, lowest assurance. It's kind of now that Let's Encrypt and some free providers are out there, it's really become the baseline for web security and TLS in general. And I'm not saying you shouldn't trust it, but there is not much more beyond a DNS or an email that is done to verify that. So most organizations have policies that require OV or higher. Down here, you actually see the public key, right? I actually removed it because it's huge, but ultimately, the public key has to be in the certificate as well. If we flip over to the next one, some extensions, right? So authority key identifier is essentially a hash of the issuer certificate, right? So that issue that was on the previous page, each one has in this case, it looks like SHA-2, a SHA-256 hash. And what these are used for is the client can actually use that to figure out who the issuer is if they have it in their cert store. It's much easier to compare that than compare the entire public key. The subject key identifier below, sorry, I'm all off on these. The subject key identifier below is the certificate itself, right? So that is the thumbprint of the certificate. And then the key usage, right? What can this private key actually be used for, right? So this is, in this case, this is a server certificate, so you're generally going to have digital signature and key encipherment. We'll talk about that in a second. The extended key usage are essentially what can the cert prove, right? In this case, you'll notice there is client and server. There's some weird history behind this. You don't technically need client authentication, but some libraries over the years had some weird requirements to do it. So most public CAs include it by default. There is no harm because ultimately you're not proving yourself as a client, you're proving yourself as a server. Down here, right, where can this client get the revocation list, right? So a CRL is literally, think of it as a flat file that gets updated with serial numbers of certificates as they get revoked, right? So these get very big. CRLs are often used as a backup option. You don't necessarily want to have to crawl through this huge text file, essentially, and see if this certificate is revoked. And down here, let me skip one and I'll go back. The real recommended way is to use OCSP, right? So online certificate responder status protocol, which uses a responder, which essentially says, tell me if this certificate is revoked, right? So it's much more efficient than downloading this entire CRL and then comparing it. But there are times when OCSP is not available, right? That requires a network connection. So falling back to a CRL is often how things are deployed. Now I'm going to step back one. If this client does not have the issuing CA for some reason, right, where do I get it, right? So this is the exact URI I can go to get the public key, this public cert of this, who issued the certificate. And the reason that's important is there's a lot of different behavior between clients, right? So a server, for example, should always send the intermediate certificate and then the leaf. They should not send the root because you need to have the root to prove trust. The reason the server will send the intermediate is because you likely will not have that intermediate because they change, there's different ones, and it's not something you necessarily need to have all, like, let's say 10,000 intermediates on your box, because ultimately you have the root that can prove trust up to it, right? So some operating systems, Mac for example, will actually cache the intermediate cert. If you've ever gone into your keychain on Mac after a few years, it's quite the mess. I like to do new keychain every once in a while. On Chrome, and I believe it's Firefox, Chrome will actually follow the CA issuers and grab it for you if the server is misconfigured, because ultimately what was happening is people were not configuring their server correctly. It was resulting in a certificate error for end users, and they said, we'll just follow the process to get it ourselves. right? So the behavior is a little bit different, but that's why all that information is in the certificate itself. Down, I already did that one. Down here is the subject alternative name. So browsers will only validate against the subject alternative names now. And this is a little bit different from something like Eep, where you're only validating the common name. So essentially, these are all of the names that this is valid for, and they will only, if you do not have anything in the subject alternative name or it doesn't match, the browsers will error out. And the reason I bring that up as important is if you use Active Directory certificate services, the default web server certificate does not include SANS by default because that template was built like 10 years ago before this was a requirement. So just keep that in mind if, a lot of people, when they made this change, they had internal web servers that were using ADCS as the server cert, and all of a sudden everyone had certificate errors everywhere. So keep that in mind. In terms of revocation, right, this is the easiest way. I tried to use passports as a great way to explain this, right? As I mentioned, the CRL is a flat file. OCSP is more of a real-time check. And so if you think about being at the airport, right, if they just look at your passport and see if you're on a list that's printed out in the morning on the desk, that's more of like a CRL, right? It's not a real-time check. It is somewhat static, and there's something manually having to be done to actually go through and crawl through that list, right? In this case, it's the officer looking through the list. Whereas OCSP would be when you go to the airport and they actually scan your passport, then they get back a green checkbox, right? So that's kind of the difference between those two. So any questions on that? Like I said, we could probably do 2 hours on just certs, but I think hopefully that gives you just, yes? So you're saying the Eep Server cert? Yeah. The Radius cert? Yeah, so unfortunately you do have to re-onboard them, right? So that's why if you are deploying specifically onboarding, or really, so let me step back. So the general overarching recommendation is to never use a public CA for Eep, right? And the reason is that CA churn, exactly what you're saying. There is a high probability in the 2 years that, in that 2 years before your certificate expires, one of those CAs got gobbled up and reissued a new intermediate. And I'm sure, I see a lot of higher ed folks, I'm sure it bites you all the time. The only time that it would be appropriate really to use a public Eep Server cert is if you're using something legacy like PEEP. And in those cases, you really should be using a configuration utility. Hopefully it's a ClearPass or an Aruba product, but it could be Express Connect, could be Secure W2, whatever it may be, to ensure that that CA gets installed correctly. So even in those cases, using a private or a CAU control is really important because you own that chain and you know it's not going to change. And you can honestly issue an Eep Server cert for 10 years if you wanted to, right? Because you control the box, you control the VMs. One thing to keep in mind specific to ClearPass is ClearPass is a full PKI built in, and you do not need onboard licenses to issue server certificates, right? So you can issue your Eep Server cert from ClearPass onboard, and you don't need onboard licenses for that. So try and take advantage of that when you can. But ultimately, if that chain changes and you were trusting the intermediate instead of the root, then you will, the devices will either fail or reprompt to accept the certificate. All right, keep going here. So let's transition over to Radius and Radsec, right? This is the world most of us live in networking. So just a kind of a quick review of Radius, just so we can kind of show the difference with Radsec. Ultimately, a Radius client is the network access device, right? So a controller and access point. It could even be an application. Some people use a Radius auth for that. And you have a server, right? This runs over UDP 1812. Ultimately, the client is going to send an access request saying there is a new device that needs to request access to the resource, right? It could be the network, it could be an application. The access challenge is used to do any intermediate communication back and forth, right? So if the server needs to query the NAS for more information, or in the case of using 802.1x, those challenge messages carry the Eep back and forth, right? Because ultimately, .1x is Eep inside of Radius, right? It's kind of encapsulated and carried. So you may see tons of access challenges depending on where you're doing your packet capture. That's just the Eep exchange going back and forth. And ultimately, you either send back and accept or reject based on policy or some other method. There's really no sense of a timeout packet, right? Timeout is the result of not getting back a response. That access accept may have just an accept, right? Let the user on. But in the case of most cases in Aruba, you're going to send back a role, a username, a policy, whatever it may be. And then a reject is generally just a reject. Now, in terms of accounting, right, that uses UDP 1813, right, a different port, which needs a different firewall request. Those are accounting requests get sent to the server, and the server simply acknowledges them, right, that they received that accounting request. That could be a start, an interim update, or a stop. So a start says, hey, I'm on the network. An interim update is generally going to be updating how much bandwidth the user has consumed, but it also may include an IP address, right? Because when you first come on the network, when you first finish your authentication, the start comes, you may not have an IP address yet. That could take a couple of seconds. So when you get the accounting update, we'll get the IP address, and that's where you kind of are online from the standpoint of ClearPass. And then an accounting stop means you disassociate or disconnected from the network. Now, the reason I harp on this a little bit is if you've upgraded to ClearPass 6.7, in the past year, the licensing, we made it a little bit more flexible and did it based on accounting. And just a reminder that you don't need interim accounting, right? Only use interim accounting if you're doing things like bandwidth quotas, because it's just unnecessary chatter between the devices. In terms of dynamic authorization, right, so this is often incorrectly called COA. So dynamic authorization is both COA and disconnect. They're not the same thing. So essentially, this is RFC 5176, and the first type of dynamic authorization request is a packet of disconnect. So this is, at a bare bones, get this device off the network. There's not much more to it. Most vendors support it, no matter what. So it's pretty standard for a disconnect. Notice that the two flipped, right? So now the NAS is the server, and the server, the ClearPass server, is the client, right? And the reason that's important is the packet flow has changed, and this is UDP, so it's a different firewall rule. So if you ever do a change status in ClearPass, for example, and it says no response from network device, chances are the packet never got there. So ClearPass sends a disconnect request. Ultimately, the server will either silently drop it, disconnect, an acknowledge, or a NAC. If the controller, I'm just going to say controller to stop the confusion of server and client. Let's say the controller, for whatever reason, did not like the request, so maybe the timestamp was off. So you can actually have hard enforcement of the timestamp for replay protection. The NAS will actually drop the packet and won't respond. And that prevents kind of an attacker from kind of discovering the network there. But ultimately, if it was accepted and the NAS disconnected the user, they'll send back an ACK. If, for whatever reason, let's say you sent back the wrong attributes, they'll send back a NAC, like they were not able to actually complete this. Now, a COA, think of as more of a vendor-specific function, right? Most of the time, these are unique to whether it's a switch or a controller, and unique to the vendor. So examples of a COA would be a change user role in Aruba world, a bounce port on the switch. Cisco has re-authenticate session, right? Those are very unique to the vendor. And they behave very similarly, right? The COA request, that is backwards, I apologize. I never noticed that, and I've been using this slide forever. Flip those in your head. COA request goes in, right? And same thing, ACK or NAC. But the difference is the contents of that. Difference is just the contents of that request. So in a bounce port, for example, let's use that. We send a timestamp saying at this point in time we requested this. And for like an Aruba switch, we send a value of 12, which says keep the port down for 12 seconds, right? So all those will vary based on the vendor and what they're trying to do. But you do have the vendor has flexibility in saying, these are the different profiles we support. And in ClearPass 6.7, we added the ability to import custom profiles to be able to take care of these different things. So let's switch over to Radsec. This is probably the most new, so I want to spend a lot of time on this. There's really two flavors of Radsec. Radsec is what I would call the marketing name, right? It's not the protocol name. And ultimately, it's radius over TLS or radius over DTLS. Those make up Radsec. And ultimately, you pick a flavor based on what your vendor supports. Radius over TLS obviously uses a transport layer security. It's wrapped inside of TLS, and it runs on TCP 2083. And then radius DTLS uses UDP over same port 2083. In terms of ClearPass support, we did support it in an early release fashion in a release of 6.7, but that was NAS to ClearPass only. We did not support a proxy use case, and we only had essentially a basic level of authorization for the certificate. 6.8 is what we're calling full support, where it's ready to go for all use cases. We support NAS to ClearPass and then ClearPass to a remote server, let's say Eduroam, for example. The event network, the Passpoint network, and Eduroam are actually running over Radsec to their respective providers, just to show you stability. The DHCP issues this morning were not the AAA. The other piece we added was NAT support. So one of the challenges, especially with dynamic authorization requests, the NAS IP and the source IP have to match. And when you cross a NAT boundary, the source IP changes from what the controller's IP is, right? You're changing to the public IP. So what we did is we added the ability for you to override that and say, expect these requests to come from this public IP, even though the controller's IP is 10.2.3.4, right? So that's big for, especially if you're deploying ClearPass in AWS, for example. You don't necessarily want to stand up VPN tunnels, and that's really the big benefit of Radsec for that use case. We also added granular authorization options for certificates, right? So you can say, from this issuer with this serial number, common name regex, SAN regex, et cetera. So you can really lock that down, especially if port 2083 is open to the internet. You want to lock that down. In terms of the difference, right, essentially everything that we talked about in the previous slides, radius accounting, and dynamic authorization, all happen inside the TLS session. So it does use MTLS, mutual TLS. There's a client certificate and a server certificate mutually authenticated to each other. The session is established from the client to the server, which is great. You don't need to open firewall ports unless you're restricting outbound, which is not very common. And everything flows over that session. That session may blip and come back. Sometimes the controller will open a second session based on load, but ultimately it is an established session, and that's one of the biggest benefits of Radsec outside of security is it's not the traditional UDP fire and forget and wait 10 seconds and see what happens, right? So it's much more responsive, better performance, and highly secure. So if you look at the proxy use case, right? So this is sending essentially, let's use we have this event network here is proxying to another set of Radsec servers running in AWS. So that's a server-to-server event that is running over Radsec. And same thing, both sides are mutually authenticated inside the tunnel. Everything's going across. And that's really the only time where you need to open flipped ports, right? So if you are essentially, being the server for a remote like let's use Eduroam as an example. If you're allowing your users from another university to authenticate back, you would have to open inbound on 2083 because you're accepting requests and their servers are initiating to you. But if you're just doing a campus to AWS, let's say, you only need the outbound. In terms of what I call the Eep Stack, right, looks like for Radius TLS, Radsec, you still have IP, right? You traditionally had UDP. Inside of the UDP, you'd have Radius, and inside of the Radius exchange, you would have the Eep Exchange. The only thing that really changes here is UDP is gone. Now you have TCP and TLS, right? It is ultimately the same Radius request inside of TLS, right? In terms of why it's so important, right? I summarized a bunch of these. TCP, all the benefits of TCP are here, right? So all of those challenges where servers get marked out of service because the UDP, the Radius request over UDP took too long to come back, all of that goes away because ultimately the controller has a session to the server, and if that drops, it's immediately marked out of service, and it may come back immediately or it'll fail over to another server. So these are huge benefits, specifically in especially universities where with services that may not be on your campus, it may be outside of your control how long that request takes to come back. So there's no more of those duplicate requests. It's a persistent session, and a lot of the UDP fragmentation issues go away. This is really important for EAP-TLS. EAP-TLS has struggled over UDP with multiple packets and fragmentation, all these things. Performance is significantly increased over Radsec, and we will actually have, I'm going to say in the next 3 months. I think it'll be a month, but I'll give you 3 months. We'll have some new numbers for proxy performance with Radsec for ClearPass. We'll talk about the security for a second, right? This is my favorite slide to show. This is the Radius RFC in 1997. That was when it was, so security, nothing has changed since 1997 with regards to security. Does anyone know what's so important about this packet capture? So this is a packet capture between a Radius server and a controller. That's one. Not quite as scary though. That's normally yes, but this is an Eep Exchange. Does anyone know what this is? Yep. Yeah, this is the key that is actually used to derive the encryption keys used for the client over the air. So if I capture this and I capture the four-way handshake, I can decrypt all of that user's .1x traffic over the air. And today, this flies across the internet all day long with Eduroam and your user's credentials in your sessions, right? So Not good. Granted, I should be fair. It would be very hard to, you have to do BGP hijacking to redirect this request on the internet, but not good knowing that that is there. All right, so that is, I think, the most core piece. And as you pointed out, some of the other things that are a little bit more, things that people seem to care a little bit more about nowadays with privacy, things like an AP name, username, MAC address, right? These are what some would consider, privileged information. That's all flying in the clear, right? So all of this would be in a TLS session, protected and encrypted. In terms of support, so we have taken, I think, a leading stance on Radsec. Keep me honest if you don't think so. But so all of our mobility controllers and instant APs have supported it for quite some time. ClearBass supports it in 6.8, and we're doing continuing solution testing between all the platforms. To give our ClearBass is a multi-vendor product, I'll give some credit to the other vendors. Cisco supports it on their 9300, running 1610. Radiator, which is a commercial product, supports it. Arrowhive uses it between their APs and Hive Manager, but I don't believe you can configure it beyond that. Keep me honest if you know it differently. And believe it or not, Mist supports it. They add it day one, which is great as part of their APs. So adoption is increasing. I got to give the free guys some credit. Free Radius and Packet Fence support it as well. Any questions on that? Go to a time check. All right, so we'll jump into 802.1x and Eep, so we keep moving essentially further down the stack here. Just one of my pet peeve slides. It's capital X. It just drives me nuts. Not lowercase x, not 11x. The 11x one kills me, but I use the emoji keyboard there too. So just a quick review of 802.1x and Eep, right? So 802.1x is the framework, right? Eep is the actual protocol, and it's designed, in the name, extensible, right? It was written in a way to accommodate multiple methods inside of it, so that they weren't stuck saying, these are the only options you have today, and you have to wait for an RFC to revise it. Instead, they wrote a framework that is then, additional RFCs could be written to be supported inside of the Eep framework. So really the terminology, right? The supplicant is the device that's trying to get onto the medium. Could be wired, wireless, VPN even. VPN doesn't traditionally use the 802.1x context, but they do use Eep. Authenticator is the device you're trying to connect to, right? That could be an AP, switch, controller, whatever it may be. And then the authentication server, let's just assume ClearPass. So when the client, in this case it's a switch, the client plugs into the switch. Essentially the switch is going to say, hello, who are you? In this case, this is all L2 between the client and the switch. The client is going to respond back with their username, and ultimately that kicks off the Eep Exchange. And what's going to happen is the client is going to open up direct communication with the authentication server via the switch. So it's direct, but it's not, right? Because ultimately, this entire exchange gets then wrapped by the switch into the Radius request or Radsec request. So essentially, up until this point, it's by itself. Then Eep goes inside of Radius between the switch and ClearPass. In terms of the different Eep methods that are out there, right? If you've known me for a while, I'm very opinionated on this topic, so take that with a grain of salt. EAP-TLS is really the preferred method, and it really is the only proven secure method at this point. All these other Eep methods on here are known to be broken, either by protocol or by the way that they're implemented by the OS vendors. So the best example, and a lot of people don't realize this, Peep is not standardized. It was actually never approved. It was designed to be used in Windows for, sorry, these buttons are different than the last one. It was actually never approved as a standard, and it was really designed by Microsoft to be used on a Windows AD joined device. It was never really meant to leak out into the rest of the ecosystem, but everyone saw the way it was implemented. That's easy. Users could just put in their passwords, and that's great. Except no one actually obviously configures the supplicant correctly to validate the server. And Eduroam is a great example of a walking man in the middle globally. If your clients are not configured for Eduroam correctly, literally they're moving around the world with potential to get their credentials grabbed. So it's really important, especially in a roaming environment, to use EAP-TLS. Peep v1, similar case, right? So the idea with Peep v1 is you can use an alternative credential like a clear text password. Maybe it's a one-time password or a token. And then you have EAP-TTLS PAP, which I like to just explain. It's very similar, nearly identically to Peep v0, except you can use alternative password hash formats. So Peep v0, Eep MS Chat v2 requires the credential to be stored as an NT hash, which generally requires you to use Active Directory. Some people have gotten it, stored an NT hash inside of LDAP, but it's not very common. So generally, if you have Microsoft Active Directory domain controllers, you're using Peep v0. If you use OpenLDAP or some other platform, you're generally using EAP-TTLS PAP. EAP-TTLS PAP requires almost the same level of configuration on the client as EAP-TLS, which is just another reason why we say just ignore all of these and do EAP-TLS. In terms of some other ones that are interesting, so Peep v2, like Peep v1 and Peep v0, was never standardized, but the idea with Peep v2 is to provide as what's called a chained EAP option, right? So essentially, I don't want to just send one credential, I want to send multiple credentials. And that may be, the common use case in Windows environment would be, I want to prove the machine and the user's identity at the same time via, maybe the machine uses a certificate and the user uses their password. There's no client support. The last I knew, Microsoft has no plans to implement this. It was really a draft RFC. It was some optimism for a while, but unfortunately it never went anywhere. Cisco went and developed Eep Fast v2. While it sounds like it's Eep Fast, which isn't a standard, it is not a standardized. It is a Cisco proprietary Eep method. It provides the same experience of chained Eep, but it requires their supplicant, the Id Connect client, which is not free. Well, that's my one jab at Cisco. So they get you on that, right? Some positive news, right? We're starting to see a lot of interest in TEEP. So TEEP is actually an RFC. It's tunneled Eep, essentially. And that does, by standard, provide capability to provide multiple authentication methods in the same request. So hopefully around this time next year, we'll be able to talk more about this as more adoption happens. But the chatting is happening between many vendors and implementers out there. So it should be exciting. In terms of tunneled Eep, I just want to talk about outer versus inner identity, especially since I know there's a lot of higher ed folks in here. This is super important. So just as a quick stat, I looked at all of the EduRoam authentications from this event, and 96% of them did not have an anonymous outer identity, which means your username is essentially flying around across the internet. Anonymous outer identity is critical, right? Because ultimately, if I do a packet capture right now and there's anyone from EduRoam, I'm going to see tim@arubasecurity.net, not just anonymous, right? So that is, a lot of people really care about that because ultimately you're binding now a user's identity to a MAC address, which can be tracked. So especially for global roaming, it's really important to provision users with an anonymous outer identity. So like using Peep or TTLS as the example where there's a TLS session established and then all of the actual credentials get exchanged on the inside, there still needs to be a username on the outside. And the reason this is used is ultimately in a federated roaming environment like EduRoam, I need to find a way to get this authentication request to the home server that can authenticate it. So I still need to know at least, at a bare minimum, at arubasecurity.net in this case. Most client implementations will append anonymous, it's not required. But at a bare minimum, I can write policy as what I'll call a routing radius server to say, if this request is for at arubasecurity.net, send it to Aruba's ClearPass servers, for example. And that's the fundamental way of that EduRoam works, right? There's 2 top-level servers in the US that service EduRoam. They are doing all this routing based on that domain because you have provisioned your servers to be the owners of arubasecurity.net in this case. Your real identity is going to be on the inside, is only seen where Eep terminates, right? So in the case of EduRoam, we'll use that again. If you are from, I'm just going to use Brandeis, I used to work at Brandeis. If I was a Brandeis user here today, your TLS session is terminating at your university, right? That's why you don't receive a new certificate prompt, right? Because ultimately, the TLS session is terminated and your real identity is only viewable by Brandeis's servers, right? And that's why, if you don't want to see this on the outside, then that's what the identity privacy knob is. And unfortunately, because many people use Peep without configuring the supplicant properly, no one ever configures this because it's another step. So to summarize, right, some of the challenges with tunneled and encapsulated Eep, it follows the tofu model, right? So when I first connect and I don't have a configuration for a Peep network, for example, I get the certificate prompt, I click connect, and I move on, right? So the first time I connected, it's assumed that that is the trusted server's identity that I should be talking to, and that's not always the case, right? Nothing tofu in security is a good thing. It requires the user to have awareness of the server's identity, right, which they don't. The server certificate's common name is going to be, in 99% of cases, probably for ClearPass, it's clearpass.yourdomain.edu, right? Users don't know what to do with that. The most they'll see in many cases is, okay, it's the same domain as my email. But in some cases, like Windows 10, it doesn't even show you the certificate's common name. Requires manual configuration if it's secure. And then it doesn't have a device identity, right? There's really no concept of a device-bound identity with these protocols, right? Ultimately, you are using the user's identity, which is not necessarily unique to this device. And the last one, is anyone familiar with Windows Credential Guard? One? Okay. Did you turn it on and then turn it off? Okay, so real quick. So Microsoft took a hard stance with Windows 10 as to really virtualize as many high risk pieces of the operating system into a virtualization layer. What they did is they created Windows 10 Credential Guard, which the idea is essentially any of these legacy protocols, right? Ultimately, Peep is using NTLM v1 at the end of the day, which is like wildly insecure. And what's happening is the network supplicant, after you turn on Credential Guard, no longer has access to that hash. So what's happening is all the security guys were like, oh, go turn this on, push the GPO. No one could connect to the network because the supplicant couldn't get the hash, and then you can't reverse that because no one can get on the network. All right, so these are the challenges with, even Microsoft wants you to stop using Peep. Specifically with Credential Guard, make sure you have a conversation before pushing that button, because it is, in a distributed environment, very challenging to reverse. I'm going to skip this just because I just did a time check. So this is kind of the exchange. You'll get a copy of the slides. The one thing I will say, the error message, which is that box when you're not configured correctly, it is not an error. It is a perfectly valid prompt, right? We get a lot of questions on community like, what is this error? How do I stop it? And the only answer is correctly configure the client. That could be manually. That could be via Quick Connect, our product called Quick Connect. It could be Secure W2, Express Connect, whatever. I don't care what you buy, but please push users through this process so that the credentials aren't being at risk when they're moving around. Even Eduroam has a tool that you can use to configure Eduroam. Those errors kind of have a different look and feel on each one, right? Each operating system. The nice thing, I'm not a big Apple guy, but I'll give Apple credit. They actually do validate the system level trust here and give you a little green checkbox and then prompt you that this is what's used for the network. iOS has unfortunately changed this many times over the past 5 years. Sometimes it's not trusted, not valid. They seem to change the text all the time. This is the old Windows 7 one, which was arguably the worst one of all time because it literally told the user to click terminate, which from a security standpoint is good, from a user experience standpoint is poor. And then in Windows, they changed it to be much more friendly in Windows 10 to say, if you're expecting this network in this location, go ahead. The one challenge that has been, the one challenge on Windows was when you click on Show Certificate Details, it would show you the thumbprint of the certificate. I don't even think anyone in the room knows the thumbprint of the server certificate for ClearPass, do they? So I do have some positive news on that. I can't commit to a date, but Microsoft will be bringing back the common name and displaying the common name there at least so they can verify the domain. So that's a positive. In terms of how do credentials actually get exposed, right? This is the basic example of the parking lot. I have an unconfigured client. They go ahead and accept the DigiCert certificate secure login.arubasecurity.com. That's great. Then they room to the parking lot. The user gets a prompt again because the supplicant's not locked down. It looks very similar, right? Network login, secure login, Aruba security is in the name. They don't really know what issuer means, right? They don't know that that's a free CA that will give anyone a certificate. They click accept, and now this server in the logs will have that user's credential. Great example. I won't name names because I'll get in trouble, but this is a very large cable provider in the United States that runs an SSID using EAP-TTLS PAP. And not only do they use passwords, that is actually my billing password. So if you were to see this in the clear, you could actually just log into my account. So EAP-TLS, as you probably, I beat it to death, but mutual TLS, no user passwords are stored or exchanged. That's the other big piece is the password's not even on the device, right? You're not actually using a password for anything. You're not transmitting it, you're not doing anything. Though I often get a question about biometrics, like all these phones started coming out with biometrics and Windows has Windows Hello for Business, and we often get asked, how do you use these biometrics in order to authenticate to the network? The big thing is you never want to actually use the biometric to do anything other than unlock a credential, right? You don't want a hash of your fingerprint traversing the network, I hope. So there's this concept of a match on device, right? Ultimately, when you enroll your Android phone with your fingerprint, your iPhone with your face, that is being encrypted and stored on the device, and it never leaves the device. Because ultimately, all that is doing is unlocking other credentials inside your key store. So on Mac, you're unlocking keychain. On Android, you're unlocking the secure element. On iPhone, you're unlocking the secure element. So the answer to this is you're still using EAP-TLS, but you're unlocking it using the biometric, right? And that's the same kind of, this isn't really new, right? You've had TPMs, you unlock with a PIN. It's the same concept, but now it's in a much more consumer-centric method. And this is just a quick kind of like, these are how the different operating systems store it, right? Ultimately, they have some form of trusted execution environment, similar to that virtualization layer I was talking about in Windows, but many times this is hardware-backed and there's a dedicated chip on the laptop. Like that's why the MacBooks with Touch ID actually have, I forget what ridiculous acronym Apple gave it, but they have a little trusted module on it. I'm not going to talk about this because this will burn 10 minutes, but this is in the slide deck as a recommendation. We touched on it earlier about the Eep Server Recommendations. The ones at the top are like non-negotiable. They have to be SHA-256 and 2048, or the Apple client specifically will barf on that. And some of these are more discretionary. Any questions on that? Sorry. I didn't even get this far when we did this 2 weeks ago, so this is good. We have 20 minutes. All right, so let's flip over to modern. Let me just do a quick break here. The Vegas air kills me. Dry throat. All right, so let's jump over to Saml 2. So the whole idea behind Saml is essentially it was designed to, really it's centered around web apps, right, and web applications. And ultimately, how do you prove a user's identity without actually storing a credential for them locally, right? Because ultimately, I think there is a general mindset that, let me rephrase. I have this general mindset that I should have two identities, my personal identity and my enterprise identity, and that's it. Everyone else should use one of those, right? Because that is ultimately me, right? This whole concept of like, I'll go on my pedestal for a minute. The fact that we all have our own driver's license versus just a passport is beyond me. Like, why do I have multiple identities? They're all me, right? And I think that's the core, this whole concept around decentralized identity, which you'll start to hear about a lot more. Microsoft is backing the DID Foundation about you should control your identity, right? The use case I'll give you is like I said, I'm on my pedestal, sorry. We overshare information that is not relevant. When you go to a bar, why do they know your birthday versus you are just 21 or over, right? So this is the whole concept of decentralized identity and all these things. And you're gonna start to hear more of it. Saml is not really specifically related, but the core concept is the same. Someone else owns your identity and it can attest to who you are in the context of an application or a service. So there's really three components. The principal, which is you. It could technically be a device. There are some provisions inside some of the Saml specs that allow device-based auth, but it's not very common. I've actually never seen a production implementation of it, so just assume it's a user. You have a service provider, which is essentially what you are trying to access, right? They are providing a service to you, and you need to prove who you are. And then the identity provider is who actually owns your identity, or in that context. That sounds very like dystopian, that they own your identity, but you know what I mean. So here's a quick example. You probably experience Saml every day. This is essentially a login to ClearPass using Azure Active Directory as the IDP. So I went to ClearPass. I got redirected to my IDP since I didn't have an active session. This process is completely up to the IDP, right? They may challenge you for an MFA. They may challenge you for a phone-based auth, whatever it may be. To the service provider, that's completely irrelevant. We just need a response back that says, okay, you are who you say you are. And that's what happened here. So I'm now logged in with that identity. ClearPass didn't necessarily care in this case how I authenticated, right? That's up to the policy that's designed on the IDP. And you'll see all the different attributes that essentially get sent back. So the idea is you can send back relevant information to that platform so that they can use that to derive things like group membership and all that kind of stuff. So I shamelessly stole this from the people who wrote Saml because it's just easier than trying to recreate something, which ends up being the same thing at the end of the day. So I just animated it. So essentially what we just saw, right, the service provider, clearpass.arubaboston.com, that essentially is the resource I'm trying to access, right? There are different components in ClearPass that can have a different configuration, but let's just assume all of ClearPass is protected by Azure AD in this case. The identity provider in this case was login.microsoft online, which is Azure Active Directory. It is running a Saml 2 service. It is also running Openid Connect and WSFed and all these other protocols, but in this case, we are choosing to use Saml. And then I have my device, right? So this bar at the bottom could be your browser, it could be your application, it could be anything that is invoking the need to prove your identity. 90% of cases, it's going to be an application or a browser. So essentially what we did, I in my browser went to go to ClearPass. ClearPass essentially did a quick session check to see, do I actually have an active session, right? Essentially is the response that was sent back previously still valid, if at all exists. In this case, I did not have a valid assertion, it's called. So essentially what happens is ClearPass says, hey, go actually redirect yourself to the IDP. So go to login.Microsoft Online. Here's a big snippet of text essentially that says what you're trying to do, who my identity as ClearPass is, right? Because ultimately the IDP, Microsoft needs to know that this is coming from an approved service like ClearPass. And that is all done back through the browser, right? So ultimately ClearPass said redirect and go here. You'll see it's a GET request. So I do a GET to the Saml service on Azure AD. At that point, I do some form of authentication or authorization gesture. Like I mentioned, this is completely irrelevant to ClearPass. ClearPass, as the service provider, may want to use the result of that in policy, but ultimately what is done over there is at the liberty of the IDP. And that's why if you are a ClearPass customer, you sometimes get vague answers from us about, do you support this MFA solution? And we say, if it's part of an existing flow, yes, we do, because we're not involved with it, right? So unlimited support, right? Marketing. So essentially, something happens here. Like I said, password, certificate, MFA only. We're getting to the point where a lot more passwordless flows are happening. Google and Microsoft are heavy on passwordless, and I'll talk about that towards the end. Maybe I just push something on my device. Maybe I have a YubiKey, whatever it may be. And ultimately, let's assume I did pass that credential check. The IDP is essentially going to send back a signed response. And this is just a giant XML payload that essentially has at a minimum, my username, which is the name ID, which is essentially the principal. And then it may have a bunch of other attributes depending on what was configured to send back. So common ones would be title, department, email address, group membership, kind of your traditional LDAP attributes. And that is actually going to be signed by the IDP itself, right? So that can't be modified after the fact, otherwise it'll fail a validation check. What's going to happen is now my browser is actually going to post back this payload essentially to ClearPass and say, here's my ticket, let me in, right? And the big thing to note here, right, there is never communication between the IDP and the service provider by default, right? There's some backend things that can be added to do some checks, but a base level SAML flow, there is no communication directly between the service provider and the IDP, because ultimately an administrator had to go into Azure AD in this case and set up a link between ClearPass and the IDP. And what that really constitutes is, what is your URI, right? Because ultimately, I don't have it on here, but ClearPass has a predictable URI, /SAML/SP. Give that to Azure AD as this is where you need to send the user. And then Azure AD, in this case, is going to give you back a certificate that is used for ClearPass to validate the signature on that. In most cases, those certificates are self-signed because they're locally significant between those two platforms. There's no need for it to be signed by a public CA because the admin has to manually add it. In terms of what's inside of these packets, right? So this is the authentication request, right? So this is what my browser has taken from ClearPass and given to Azure AD and said, authenticate me. You'll notice here, this is essentially saying, where do I need to send this user back to once they have their assertion? Once I've given you the assertion, where do I need to punch you back to? Because ultimately, like I said, this is in the browser, so the browser needs to know where to go. You'll see force auth n is a cool thing. We actually don't support it in ClearPass, unfortunately, but you can actually configure some platforms to say, no matter what, even if the user has an existing single sign-on session, force them to authenticate again, right? So it's more of a security feature there. And then you have essentially this is the identity, what's called the entity ID of ClearPass that needs to be configured inside of Azure AD, and Azure AD will say, okay, this is essentially a valid whitelisted service, and that gets bound essentially to an application in the IDP, which may have its own permission levels and all of that, right? So think of essentially a mini ClearPass in the IDP that has its own little rules engine, and that's going to vary by platform. So some other, actually that's a duplicate slide, sorry about that. So then assume everything went well, I passed my credential check, my authorization check, whatever it was. This is actually the response that's sent back, and inside of this is the SAML assertion, right? So you'll see a lot of information around signatures and certificates. Essentially, it needs to be declared how this request was signed and hashed and all that fun stuff, right? So ClearPass knows how to decode it. Down here, you'll actually see the certificate that was used. Remember, this is only the public side of the key that was used to actually sign this. And if we, let me step back, and you'll see status code success. This was a successful Saml request. And if you look down here, the assertion ID is essentially a unique identifier for this. And down here, this is where all the fun stuff happens, right? So this is saying, you know, the principal, right, the person that this is for that was asked to be authenticated is, in this case, tim@arubaboston.com. And in this case, the username is in the format of an email, right? 90% of federated identity use cases, which this is, will use a fully qualified username. That's why we highly recommend, if you're building a new ClearPass infrastructure, or really anything around identity, force your users to use a fully qualified username. It will save a lot of headache later on. And if you have questions about that, we can talk after. In this case, it's saying in response to, right? So ultimately, that is the ID of the authentication request. So ClearPass can correlate it, make sure it matches on the way back, so that if there's 100 of these requests coming back and forth, this is the response to that. And generally, a SAML assertion is going to be valid for 10 minutes. So it's saying not on or after this time. If we dig into some of the other attributes, right? In this case, sorry, it's really hard to see from here. So in this case, Microsoft, for example, does actually pass back how I authenticated. So in this case, I use my password, my name, company, display name, and like I said, that could have a bunch of other attributes depending on how it's configured. And this follows the typical security mindset: don't send back more than that's required, because ultimately, you know, a user can see this in their browser, but you know, the bigger the payload, the longer it takes. Typical kind of practices there. So to quickly transition into Openid and OAuth, they really follow the same mindset, right? But they were really designed with a little bit more of a futuristic methodology and programmability in mind. So you have this concept of a resource owner, right? So let's use Dropbox. So I own my Dropbox account somewhat, and you know, I should be the only one who has access to my Dropbox account. The client is how I'm trying to access Dropbox. That could be a browser, it could be an app. It could be, you know, whatever, your TV, who knows. The resource server is probably Dropbox.com. And actually, I just realized as I'm talking, this is a terrible example because the authorization server is also going to be Dropbox.com. So let me start over. Let's use signing into the New York Times with Facebook. So in this case, I own my Facebook account, or Jeff Zuckerberg does, I guess, and so does everyone else he shares our data with. The client side is essentially the same thing. It could be the New York Times app. It could be the browser, whatever it may be. The resource server in this case is some asset on NewYorkTimes.com. It could be a cache. It could be some form of service that they're providing data to us. And the authorization server in this case is Facebook, right? We are using our Facebook account to log in. And the result of that process is ultimately I need to get back an access token that I can exchange for access, right? So think of this as like an ephemeral password that's only valid for a certain amount of time. And I'll talk about refresh token in a second. So you should see, I guess the moral of this is there's similarities, but this is a much more modern mechanism, and it's really designed less around just proving a user once and more around delegating access, right? So the idea that, you know, for Dropbox, for example, you are delegating access to, let's say, you go to a kiosk. Well, that's a bad example. It's terrible security. You need to give access to someone or someone other's service on behalf of yourself to Dropbox, right? It really is a framework to be able to have dynamic authorizations and control. In terms of the different ways it works, right? So there's ultimately the four popular grant types, right? So it essentially operates in an operating mode, right? You are requesting a token or access in some form of state, right? Some form of mode. Authorization code is the most popular, right? And this happens in what, you know, it's called a three-legged approach, right? A three-legged OAuth. And essentially that is where you're using your, you know, let's use Google as an example. You're using your Google account to sign into another service. Ultimately, you are proving to Google who you are and then exchanging back some form of data to the service you're trying to access that they can then validate and let you on. So it's the same idea as that you don't necessarily want to have 100 bazillion accounts, right? You maybe want to use, I have 3 primary accounts that I want to log into everything else with. Maybe I don't want to give those companies my full information, right? I only want them to link it to my Google account or whatever it may be. There's a lot of different reasons for this, but ultimately it is kind of the foundation of the internet today. On the resource owner password grant, think of this more like just a normal username and password auth into anything, right? Ultimately, the username and the password are being sent as part of the request, and we're getting back some form of token that is used from then on out. Generally, this is used with native apps only, right? So for example, if you log into the Facebook app, Facebook owns that app, they write the app, there's really no need to then send you to facebook.com to request the same information. It's ultimately going to the same place. So it's very commonly used in a native app. Authorization code is generally when you're using a third party or you need to grant access to something else. So if I'm using a third party Twitter client versus the Twitter app, you're using generally an authorization code so that you can talk to Twitter and then take what Twitter gave you and give it back to the app. Client credentials, think of like a service account, right? It's essentially when a machine wants to do something on behalf of another machine. So it does not use a user account specifically. It uses a client ID and a client secret, which at the end of the day is essentially a user account, which is ironic. But think of that more like a service account. And the last one is a refresh token. The idea with a refresh token is to essentially refresh my access without making the user go back through the same process again. Does anyone use the Outlook mobile app? Does anyone use it on a tablet? So I use a tablet, but I don't use it every day, and I'll go sometimes a week without using it. The best example is if I don't open the Outlook app for 7 days, the refresh token is no longer valid and I have to go through the same process again. Whereas if I opened it every single day, the refresh token would continue to get refreshed. So the idea is as long as that is still valid, you can continue to use it to get a new token until either the time is up, right, there may be a separate expiration, or the token is revoked, right? So if your account gets disabled, or actually, Office 365, for example, will revoke all your tokens when you change your password, you will just be able to continue to use it unless some other event has happened. The minute you let the refresh token expire, you have to go through that full process again, and the user has to log in and do something. Openid Connect is very difficult to explain. So OAuth is really for authorization, but it was kind of, everyone built their own kind of authentication layer on top of it, but it wasn't really necessarily, I don't want to use standardized in the sense of like IETF, but it really wasn't consistent, right? So if you're familiar with like OAuth 1 and OAuth 1A, they were kind of a nightmare. All the kind of legacy tech companies did their own thing. They didn't really work well together, which was the whole point of this. So essentially, Openid Foundation came up with this concept of Openid Connect. And you'll notice everything's very similar, right? You have an end user, the user agent, which is the thing, the device or the browser you're trying to access things from. Ultimately, the service you're trying to access, and then the provider that is proving who you are. The new piece here is the identity token. And the identity token is this concept of it's assigned, it's similar to a Saml assertion. I think that's the best example, because ultimately it's a blob of data with certain information about you that is signed and encrypted with some form of key, right? So it's much more like a Saml assertion than it is like OAuth, because ultimately OAuth is returning back an arbitrary token, whereas this is returning back essentially a timestamp, a username, maybe some additional data like in the Saml assertion that the service you're trying to access can go through and validate, and even maybe check it in real time against another service. So it's really designed to provide that standard layer across the board for OAuth. It essentially, it's part of OAuth and it's not. I don't know really how to explain it. So this is an example of an identity token for Azure Active Directory. You can see these in your browser. You can actually detect them, and Azure, Microsoft has a cool little test tool that you can see what they are. Ultimately, they use what's called a JSON Web Token, and the JSON Web Token is essentially an encrypted and signed, I'll just keep saying Saml assertion. It's very similar. Essentially, you have the first little blob of data, which is this is a JWT, and what algorithm is actually used to encrypt it. This is actually not encrypted, so that's why it says none, because we can see it. And then you'll see audience. This is a locally significant identifier. Who actually issued this token, right? So Microsoft uses a token service, and this is essentially the identifier they use internally. That would actually be relevant to the application you're trying to access because they can go validate it against that. Then you have some timestamps, not before, I forget what IAT is, and then expire, when does this actually valid to. A lot of these are going to be unique to the provider, right? So OID, for example, I believe is your UUID in Azure AD. And then you have some more kind of common attributes like UPN, unique name. And like I said, these are going to vary by platform. And then the last little blob of the JSON object is the signature. And if you look in this blob of text up here, you'll notice, and it's very hard to see from this distance, there are periods in here which literally are separating these blobs, right? Because ultimately this signature takes all of this and signs it, and that becomes the blob after this. So it looks like almost like a certificate. So there it is. So that's this first blob there. All of this down to here is this, and then it's not signed and encrypted because we can see it. But that would be the last blob. So that's kind of the core concept with an identity token. The cool thing about Openid Connect is you can actually see the configuration, right? Every Openid Connect compliant server will actually publish its configuration for Openid Connect at a predefined, well-known URI. So you can actually go to, you can actually view Microsoft's, this is right from there, the platform. And the idea here is that services can discover each other. You shouldn't necessarily have to configure all of these different knobs to have these two services talk. It should just be, I am configured for Openid Connect between these two platforms, go figure it out platform. And that's what this does, right? So it essentially says if I need to get a token, I go here. If I need to do an authorization request, go here. Azure AD is going to send back a code, an identity token, both a code and an identity token, et cetera, right? So it's really a metadata to allow the device to auto-discover in a way how it needs to communicate back and forth. So this is something that traditionally for Saml, for example, would have to be manually and statically configured. And that's not to say you couldn't statically configure this for Openid, but it really defeats some of the points of these configuration files. Anything else interesting in here? Okay, so claims, right? The whole idea with claims, that's both an OAuth term and an Openid Connect term. These are generally going to be unique to the IDP and the service. So when you, for example, in ClearPass configure Google social login or Facebook, we are asking for certain claims about the user, right? In the case by default, I believe we just ask for the name. You may want to ask for the email address, right? Ultimately, those are different levels of context and privacy based on the platform. So you may have to configure something separately to say, I want access to the email address. And maybe the administrator of well, Facebook's a bad example, but let's use Azure AD. Maybe the administrator doesn't allow an end user to give that piece of data to another company, right? So claims are literally what types of data, as it says, are you claiming about them? And I have 10 minutes. This is actually lined up perfectly. This has never happened. So the whole concept of this, right, these are all kind of evolutionary into each other, right? So the kind of last step, which is today, we're at this concept of FIDO2, which really is a framework that encompasses something called WebAuthn and Ctap. You probably heard a lot about this in the past few months. The biggest players in the industry are backing it, and there's already significant support across device vendors. So the core prop, right, in long term is no passwords, right? So if I create a brand new account with a service that I've never done business before, I've never had an account, I either plug in my security key, maybe it's on my phone, maybe it's on a Mac, for example, or Windows, it's in the secure element that I already have. Go ahead and enroll this with a credential, right? And the idea is that maybe, let's say the next version of the next Facebook, right, whatever that is, maybe I never even have a password with them, right? Because ultimately I have some other physical or virtual object that can prove who I am. And the big piece with this is you need at least two, right? So there's a lot of hype around this, but no one's really telling you when you buy one YubiKey, you should buy two, because ultimately you want to have a backup. But the idea is that there's something physical, and it's kind of ironic that everyone used to complain about the RSA token, and now it's like a cool, sexy consumer version. But the difference nowadays is that it can be on your phone. Your phone, fun fact actually, Android is now the largest, because how many billions of Android devices there are, they are the largest FIDO2 authenticator in the world now because they baked it into Android. So very, very cool stuff. The adoption is finally there for these types of technologies. And the funny thing, kind of inverse of what we talked about earlier, it's just using public key cryptography without the certificates, right? You don't have to use certificates to necessarily prove an identity, because ultimately in this case, I need to prove my identity to Google, let's say, and no one else needs to validate that except Google. So if Google is who my account is with, why do we need an intermediary to tell me that I should trust them, right? So the whole idea here is, I stole this diagram from W3C. The whole idea is that as the application that's requesting access and giving, let's keep using Facebook. So I have a brand new Facebook account. Let's say they are fully FIDO2 set up for WebAuthn. I have a physical, looks like a little USB stick. Plug it in. It says start enrollment. They then say, okay, tap the device, right, to prove proof of presence, it's called, right? I am here and I'm touching this device. At that point, the little device, YubiKey, it could be anything, generates a public key, private key pair. The private key obviously stays on the device, similar to a TPM. And then the browser sends the public key off to Google. And that's now, what did I say, Facebook? Sorry, getting all of them to Facebook. And that public key is now stored with my account. So now anytime I need to be challenged for this, what happens is the service looks for, Google, for example, sends me a piece of text. I sign it with my private key and send it back. It's just a challenge. And at that point, I have proven that that is my account. right? Because there's physical proof. And like I said, it could be virtual. It could be on your phone, but ultimately it's still physical somewhere in your phone, right? So this is a really, really, really cool option, right? And the concept of Ctap, right? So we had WebAuthn, which is really what runs in the browser. Ctap is essentially the bridge of the physical to digital world. So client to authenticator protocol is what it stands for. And this allows you to use USB, Wi-Fi, and Bluetooth, and NFC even, to transport this exchange, which makes it really powerful, right? Phones, you can have an authenticator that you just tap your phone to, right? It's pretty powerful. You never have to plug it in. It could exist. Wi-Fi probably isn't as common, but Bluetooth, right? The Titan key from Google, if you're familiar with that, that is a FIDO authenticator. And the whole idea is never actually have to use a password. And it also makes things phishing proof, right? You can never really be tricked into logging into a fake site because you only have a key pair that's valid for Google, right? In terms of the way they operate, right, there's really essentially single factor and multi-factor mode. Single factor, like I mentioned, is it lights up and it says touch the button. So that's proof of presence, right? Someone is there at this computer. It's not automated. Someone has physical access to this device. Multi-factor is essentially, it could be a PIN, it could be a fingerprint, face, whatever it may be. That's going to vary. And they can operate in different kinds of modes in terms of it could be a single factor, right? So and that's the case of I'm replacing my password altogether. God, I keep doing that, sorry. I'm replacing my password altogether, and I never have a password, let's say. Or it could be a traditional second factor. So the first time you log into a device, I do use my password, but I need to set up a second factor. And in certain conditions, maybe your location changed, whatever it may be, that second factor is required based on whatever the server says. So the kind of the most common one you hear about is YubiKey. They were instrumental in the development of these protocols and standards. The other one which are interesting, these are from Fission, and they actually do on-device matching of biometrics, right? So actually, I can actually, instead of using the fingerprint on my laptop to do it, the credential will not be used on the device until I actually locally validate, which means it's, the signature is not even sent or validated until I do that, right? So that's an interesting use case. And what's really cool is this is going to be heavily integrated into Azure Active Directory, which is obviously the kind of, traditional AD is kind of on its way out. And what's really cool about this is think about an airport or somewhere where, person at a computer is very quickly entering and leaving the terminal, right? They're constantly in and out. Someone else logs in. These are actually kind of, the computer doesn't need to know anything about my account. Like traditionally, you'd have to log in once, right? So that it talks to AD and does all the stuff. I can literally take one of these, plug it into the machine, fingerprint, and I am logged in as me, right? In like 2 seconds, which is very, very cool for shared workstations. And those type of scenarios, more what I call kiosk mode, where people are constantly in and out. So imagine that as a replacement for things, traditionally like things like PIV cards and smart cards. And it's the same level of encryption. The FIDO2 is actually all elliptic curve as well, which is cool. All right, and that is it. Oh, wow, this is the first time I've completed this session. So yeah, thank you for coming. If you can give feedback, that'd be great. And I'll be around if you have any questions. And if you want to see this content next year in a different form, like broken up, let us know because we just keep cramming it into one session every year. Hey, how's it going?